Hello everyone, welcome to my YouTube channel. So today we will be diving into another design principle of solid design principles, that is dependency inversion principle. So which is also known as DIP principle. So dependency inversion principle states that high level modules should not depend on low level modules and both should depend on abstraction, or we can say this principle is all about reducing the tight coupling between different parts of your application by depending on abstractions rather than concrete implementations. So we will be trying to understand this principle through an example. So let's start our example. So I have a class credit card, and here we have one method public void do payment, and here we have some logic to do the payment using credit card, and finally we will be printing payment is done or payment is processed using credit card, right? And I have one class, that is payment processor, which is tightly coupled with credit card class, credit card. And let's make constructor to initialize this credit card, and we have one method in this class void process payment, and here so we will be calling the do payment method of credit card, right? And okay, so in payment processor, so we have main method, I have credit card instance, and payment processor. So we have initialized this class and passed the credit card, and finally we are calling process payment. So till this point, if I run this program, so everything is working perfectly fine. So payment is processed using credit card. Now for example, we have introduced another payment option, that is debit card, and this class also has the method public void do payment, so which contains the logic to process the payment using debit card. And after all this logic execution, so finally payment is processed using debit card, right? Now for example, here in payment processor, so client don't want to use credit card, but he wants to use debit card. So look, how many changes we will have to make. So number one, so this class which was tightly coupled with credit card, so we will have to make a change here, debit card, and constructor will also be accepting debit card, and here debit card equals to debit card, and in process payment as well, so we will be calling debit card dot do payment, and here we will be making instance of debit card, and we need to pass this instance to the payment processor, and then we will be calling. So if I run this, so now the payment is processed using debit card, but the design we have followed is not the correct one. So it is not following the dependency inversion principle, because our high level module or high level class is tightly coupled with the concrete implementation, or we can say the other classes. But this is not the case. Dependency inversion principle states, like, principle is all about reducing the tight coupling between different parts of application and depending on abstraction. But as of now, you can see our high level design or high level module is tightly coupled with the other parts of the application. So we are clearly violating the dependency inversion principle. So let's correct this approach. Uh, Let me make one package that is bad design, and let me copy the bad design all files into this package, and I'm creating another package that is for good design. Let me copy all three classes into the good package as well. So here, first of all, rather than creating these independent payment method classes, so I will be creating one interface that is payment method. So I have this interface, and we have one method, public void do payment, and the credit card class, so I am implementing from payment method, right? Similarly, debit card implements payment method, and here, as my payment processor class was tightly coupled with my concrete classes, so rather I will change this to payment method, and here my constructor payment method, and this dot payment method equals to payment method, and here in process payment, so payment method dot do payment, right? Now the see the changes here. So I will be making payment method equals to debit card, and I will be passing this payment method. So now my payment processor class or my child classes, they are depending upon the abstraction. So now you can clearly see uh, the payment processor class is not directly depend upon the concrete implementations, so but it depends upon the abstraction. So no matters what object we are passing, whether it is credit card or debit card, but without making any changes, we can process the payment using process payment method. And here, now see, in case of debit card, so if I pass the credit card, even then I need not to change any code in my payment processor class. So because we are not depending upon the concrete implementation of various payment methods, but our code is depend on our code is depends upon the abstraction over these payment methods. This is all about the dependency inversion principle. If you have any question, you can do comments in the comment section, and we will be meeting in our next video. Till then, happy coding. Thanks.